Hi guys, welcome back to the channel. Today we're going to go over some chi-squared for dependence question here. So I'm doing it in Excel, but you can write it out on paper. I just thought it was a bit easier since my sketchpad is not working correctly. So we have this contingency table here for app consumer satisfaction survey. So we have people who'd recommend the app, yes or no, for app 1, 2 or 3. So the first question says, for the app example, calculate the expected number of consumers that it should be for each application and the yes or no pair under the assumption of dependence. So we're going to use this equation here for the expected value, which essentially, if we just look at the end here, is the column, so total for app 1 times the row total divided by the total number there, 480. So for number 1, again you can write this out on paper, I'm just doing it on Excel. We can calculate 290 times 96 all divided by 480, which gives us 58. And if we do the one below it, so for app 2 no, we do equals 190 times 96 divided by 480 to give us 38, and we should see the total should be the same if we do it across. I'm going to fill out this table now and you'll see the final results. So here are the final results for the expected values for the apps and the yes no pairs. As you can see, our totals for each app equal our original, which is what you can check for, and the same with the yes and no. And if this 480 or whatever number you have for the contingency table is the same, that's a good way of checking. So that's 4 marks for question 1. For number 2, it's asking to perform a chi-squared test for independence for the app study. What do you conclude? So firstly, we're going to calculate using this formula. First, we're going to do it in each app first, and then we'll sum them all up at the end. And then we'll use degrees of freedom to find out what we conclude. So for this, we want to do n1, which is our normal value, minus the expected value, all squared, divided by the expected value again. So you can write this out on paper, but I'm going to do it on sheets. So we have the brackets of n1 minus the expected value, squared, divided by the expected value again. Oh, I've done something wrong there. I put an and in by accident. Squared to give us 4.98. So I'm going to fill out this table and I'll get back to you. Pause the video and have a go yourself. So we get this total here with our values in here. So the next thing to do is to sum them up. Again, use a calculator for this, but if we just go sum and I just put them all up, we get 24.06. 046, sorry. So now we figure out our degrees of freedom, and as we know, we've got a 3 by 2 table here, and our degrees of freedom is 1 minus each row and column. So we do 3 minus 1 times 2 minus 1, which is essentially 2. Oh, we've got equals in there. Oh, we can just call that 2. We know it's 2. So then we pull over our dependence graph here. We look across because we want to find the 95% confidence interval. So we go point to 0.05. and we find degrees of freedom 2, we follow it down to get 5.911. So we know, if I merge all these cells together and wrap it, we have, so I'll write a little text and get back to you. So we can conclude that for a 3 times 2 table, the degrees of freedom is 2, as we figured out here. For a 5% significance level, the 95% critical value for the chi-squared data with 2 degrees of freedom is 5.99, as we saw on the table. And then since our value is above 5.99, we can there have evidence to reject the null hypothesis and conclude that there exists some sort of dependence between the different app users and whether they would recommend that apps to their friends or not. So that's all the question we're going to do for today. Make sure you like, subscribe, and I'll see you in the next video. Goodbye.